Hello everyone and welcome to the video lecture worksheet on the menstrual cycle. So if you don't have this in front of you already, I highly recommend downloading and printing out this menstrual cycle worksheet that we'll be filling in today. So before we get started writing anything down, an orientation to the worksheet, we're going to be breaking down the menstrual cycle into two major different cycles. One of the cycles we'll be talking about is the ovarian cycle, in which we're going to look inside an ovary and we're going to look at what is going on with the follicles in there and other structures. And the other cycle within the menstrual cycle is called the uterine cycle. And here we're going to be analyzing what happens to the wall of the uterus over time and how all of this relates to hormone release. So another thing we should sort of recap before going into the details is this whole worksheet is essentially focusing on what's occurring in the HPG axis. So the HPG axis is the hypothalamus, the pituitary gland, and the gonads. In this case, since we're talking about the menstrual cycle, the gonads are going to be the ovaries. So we're talking about how hormones are flowing through this axis, as well as not just the gonads, but how those hormones are influencing the uterus. All right, so let's talk about the ovarian cycle first. So in the ovarian cycle, we have these different phases. We have the follicular phase and we have the luteal phase. And right in the middle of them, we have ovulation. So follicular phase, this is going to be days 1 through 14, roughly, of the menstrual cycle. Then ovulation is then at the end of day 14 or on day 14. And then the luteal phase will be days 15 to 28. So as you can kind of tell here, we're going to be dealing with a menstrual cycle that is a 28-day cycle, which is the average menstrual cycle length. Maybe just a quick note about this down here. So 28 days is going to be the average. But it can vary from, let's say, 20 days to 35 days. So just to give you an idea of the range here. And for the most part, the reason why people might have a shorter menstrual cycle or a longer menstrual cycle depends on that follicular phase. So some people have a shorter follicular phase and some other people have a longer follicular phase. In general, the luteal phase stays more or less the same between individuals. All right, so what's the purpose of both of these phases within the ovarian cycle? So the follicular phase, it has the purpose of developing and releasing an egg. So develop and release an egg. Sometimes it's more than one, but for this worksheet, we're going to pretend that just one egg is being released, which is the average amount of eggs released during each menstrual cycle. During the luteal phase, its purpose is to prepare the uterus for implantation. What this means is that the luteal phase is going to help prepare the uterus for implantation from that egg that was released, which eventually would possibly get fertilized by sperm, and so that sperm and egg combination, the embryo, is going to maybe implant in the uterus. Other side note, in this worksheet, we're going to focus on pregnancy not happening. So we're going to just think about a typical menstrual cycle, which results in no fertilization. Okay, so these graphs, you can see there's several of these graphs here. The y-axis is not defined here, but it's some amount or concentration. And then on the x-axis, we have time. I know it's kind of a weird graph, but the x-axis starts down here. So this is going to be day 0. This is going to be day 7. This will be day 14, day 21, and then day 28. So this is our x-axis in days. So starting from day 0, something that we can notice here is that there's a higher concentration of this hormone called FSH. That stands for follicle stimulating hormone. This FSH hormone is in higher concentration than this hormone here, which is LH. LH stands for luteinizing hormone. So we start off with higher FSH than LH, and then at around this point, the concentrations of both hormones are the same in the body. And then after that point, LH is higher than FSH because FH starts to go down. And then both of them start to increase in concentration, although LH increases way more in concentration than FSH does. Then in the luteal phase, they both sort of are flat for a while, with LH being higher than FSH. And then at the very end of the menstrual cycle, the FSH will overtake the LH, resetting it back to the beginning of the cycle where FSH is higher here than LH. So it's a cycle, so the end here feeds directly back to the start here. Okay, so tying this to the axis, the hypothalamus is producing a hormone called GnRH. That hormone, when it's released, stimulates the pituitary gland to release the hormones FSH and that hormone LH. Those hormones can then have an effect on the gonads, in this case, the ovaries. And we'll see how those hormones affect the ovaries in just a moment. So what can be a little bit confusing at first when you see this graph is that we have FSH and LH concentrations, but we don't see GnRH concentrations. And because GnRH stimulates FSH and LH, you would expect that the concentration of GnRH is highest right here because there's the most LH and most FSH. But it's going to be a little bit more complicated than that. So if we're thinking of like, where is GnRH in this graph? GnRH is released from the hypothalamus in sort of a funny way. It's released in pulses. So you have low amplitude pulses that are sort of slow. And then you get a surge. And then you have low amplitudes that are even faster. So it's not quite as simple as like a line and then bumps up and then another line. The GnRH concentrations are very complicated and has to do with the amplitude of how much is being released as well as the frequency, how fast those pulses are, to determine how it stimulates FSH and how it stimulates LH. So because it's really complicated, I'm not going to test you guys on what exactly the concentration of GnRH is in this graph, and that's why we're omitting it. And that's also why textbooks omit it, because it's just a little bit too complicated for an introductory class. Not only that, GnRH also works together with another hormone, estrogen, and progesterone to change FSH and LH concentrations. So there's just too much going on. Okay, that's enough about GnRH for now. So let's start with step 2, which I know is going to be kind of weird, but let's skip step 1. We're going to start with step 2. In step 2, we're going to have an increase in FSH. You can kind of see that happening already back here. The FSH is increasing. And then here it goes up a tiny bit more. So this little increase in FSH is going to stimulate follicular development. All right, so how does that happen? To see how this FSH stimulates follicular development, we have to look at the ovaries. So let's draw a couple of things here. Of course, the hormone has to somehow get into the ovaries, so we're going to need capillaries. Let's draw a cross section here of a capillary. So blood plasma, red blood cells would be in here. Hormones would be flowing through this capillary. Okay. We have some other cells hanging out around there. Let's zoom into this part. We'll discuss what these cells are in just a moment. All right, so to start follicular development, we need to start off with these cells here and make them turn into a little bit more mature version of that cell. How do we get this less mature follicle to turn into this more mature follicle? We need that hormone FSH to leave the bloodstream. And that FSH is going to cause the conversion of this less mature cell into a more mature cell. When a female is born, so at birth, a female has 400,000 or 400K immature eggs in her ovaries. But by the time puberty hits, there's going to be more like 60,000 or 60K that are left over. So the majority of those immature eggs start to die off by the time puberty's coming around. And then out of this 60,000 immature eggs, only 400 roughly will ever ovulate, will ever be released from the ovary. The rest essentially will be dying off. So these initial cells that I drew here are part of the 60,000 immature eggs that are in the ovaries around puberty. When FSH comes in, it's going to stimulate the development of several of these immature eggs. So one way to think about it is that it's stimulating a cohort of follicles. Write it like this. So monthly, so every month, cohort. There's a cohort of follicles developed together. So it's kind of like, if you're in the freshman class of college, all the freshmen are a cohort of students. Or in high school, right? If you're the class of 2000, then you're the cohort of the year 2000 grads. So a cohort is just a group of things happening at the same, kind of going through something at the same time. So we'll have many of these eggs in this cohort together when FSH stimulates them, and they all stimulate to be a little bit more developed. So many of these little eggs are going to turn into primary follicles. Now, I'm only drawing this one being converted because I don't want to spend too much time with more arrows. So just know that it's not just one of these, it's several of them turning into several primary follicles. Now, just like a cohort of students in a college, not every single student in that cohort is going to graduate. So with these eggs, not every single immature egg is going to be ovulated. Just one, on average, is going to be ovulated. And the one that actually gets to be ovulated is going to be the one with the most FSH receptors. And that kind of makes sense, right? Because if FSH is the hormone that stimulates the development of the immature egg, then it makes sense that the one with the highest number of FSH receptors is going to be more likely to be developed more quickly. So all the immature eggs that don't have as many FSH receptors, they will end up dying off. All right, so from the primary follicle, we're going to get another kind of follicle. So continued development. It's going to get a little bit bigger. It's going to even look a little bit different too. The follicle is going to look like this. The FSH is continuing to develop the follicle here. And this guy is called a early secondary follicle. Oops. Development continues, gets a little bit bigger, then it becomes a secondary follicle. And eventually, this secondary follicle will undergo sort of like a exocytosis with the ovary, which is not quite exocytosis, but it's similar to it, where the wall of the follicle here is going to fuse with the wall of the ovary. So here I'm drawing the outer layer of the follicle. So this one right there now becomes this as it fuses to the wall of the ovary. And then the contents inside the follicle, like the egg here, here's the egg with the nucleus right in the middle. That egg is ovulated, being released from the ovary. And sometimes we give the name the egg oocyte. Oocyte is just another name for egg. Okay, so this is kind of the general idea up until ovulation. And you can see FSH has a really important role in developing the cohort of follicles. Eventually, you just end up with one secondary follicle that is going to fuse with the wall of the ovary, releasing one egg on average. So now let's make sense of why the hormones are fluctuating here. Why is it that FSH goes down while LH starts to go up and FSH doesn't go up as much? So the key here is what's going on inside these follicles. So once FSH develops the immature eggs into early secondary follicles, something that the early secondary follicle starts to do is it starts to produce a low amount of estrogen. And this inhibits LH. So it inhibits the release of luteinizing hormone from the pituitary gland. That's what the estrogen is going to do, or one of the things that estrogen does when it's in low concentrations. This is what we'll call step 3. This is helpful at this stage because LH, luteinizing hormone, is associated with ovulation. And we don't want ovulation to happen yet because this egg is not fully developed. Gotta wait until it's fully developed in order to ovulate. So we want to block luteinizing hormone for now, and then let the luteinizing hormone increase in concentration later on to allow ovulation to occur. Hopefully that makes sense. All right, so low estrogen blocks LH. The secondary follicle here, so now that it's bigger, it actually produces a high amount of estrogen. Let's see. All right, so that high estrogen, one of the things it does is it blocks or inhibits FSH. The secondary follicle, because it's blocking FSH, you can see this decrease, this slow decrease happening on the graph. But this doesn't help explain why then FSH increases in concentration. How can it possibly increase if it's being inhibited? So this is probably the most confusing part of the whole worksheet. The high estrogen, so just get ready, the high estrogen inhibits FSH, but it also stimulates GnRH. And what does GnRH do? It stimulates FSH. And it also stimulates LH. So high estrogen actually both inhibits and indirectly stimulates FSH. So what you get as a result is initially it's kind of decreasing, but then it starts to increase as the GnRH starts to be released more from the hypothalamus. But its increase is stunted because it's being inhibited still by that high estrogen. So we have a stunted increase of FSH. Meanwhile, LH is no longer being inhibited by the low estrogen here because now we have a high amount of estrogen, and it does a totally different thing where it stimulates GnRH, which stimulates LH. No inhibition of it. So we get a full surge of LH happening. This combination of high luteinizing hormone and relatively lower yet slightly increased FSH allows ovulation to happen. Of course, those hormones need to be able to enter the ovary, so we can sort of indicate this by drawing another capillary. And we can indicate the FSH leaving the capillary and resulting in ovulation, as well as the really high quantity of luteinizing hormone. And of course, the FSH and LH surges are because of the high GnRH. Or you could also phrase it as because of the high estrogen being released from the secondary follicle. All right, so common questions that usually arise in class about this process is confusion about how is this part happening? How is the secondary follicle fusing here? And so I'm just going to reiterate one more time here that the wall of this follicle, let me do it in a different color. Did my pencil here. So the wall of this follicle, similar to exocytosis, although not the same, becomes this, it's the same structure as what I drew here. It's the same thing. I know I drew it a little bit bigger. It's not really on purpose, kind of on accident. But so it's the same structure, and then the contents on the inside, this egg, this oocyte, then gets popped out and now is exposed to the external environment outside of the ovary. Eventually, this will enter the fallopian tube, and if it gets fertilized in the fallopian tube, it could implant itself in the uterus. All right, so this is so far the summary of the follicular phase and ovulation. Now let's go to the luteal phase. So remember, the purpose in this case is to prepare the uterus for any potential implantation of an embryo. So how does your ovary involve itself with helping your uterus? So this structure here, which we were just looking at, this thing that was the surface of the secondary follicle, then gets almost like endocytosis, but not quite. It's going to get sucked back, not the egg, but this wall here is going to get sucked back into the ovary, and it's going to become another structure called the corpus luteum. Oh, and by the way, I think I forgot to put some steps here. We can say this is step 4. And then step 5 is the ovulation. So this here would be step 6. The corpus luteum eventually degrades, gets a little bit smaller, maybe a little bit wrinklier, and it continues to get smaller. So this is the degrading corpus luteum. So the corpus luteum, as it exists here and as it degrades, is going to be producing hormones, and these hormones change as it degrades, which causes changes in the uterus. So let's start with the corpus luteum in step 6. When the corpus luteum is formed, it's going to be releasing a high amount of progesterone. And high quantities of progesterone hormone inhibit GnRH. This is useful because we don't want to continue any ovulation. We just want to release one egg on average. And so we want those hormones to go back down. So how do we get LH and FSH to go down? We have to inhibit the hormone from the hypothalamus, the GnRH hormone. Progesterone isn't the only thing that the corpus luteum releases. It also releases a high amount of inhibin hormone. Inhibin, which of course is going to inhibit something. And what does it inhibit? It inhibits FSH. This makes sense perhaps here because at this stage of the menstrual cycle, there's no reason to want to develop follicles right now. You want to prepare the uterus for implantation of the embryo that might already exist. There's no reason to focus on the development of more eggs or follicles. So it's going to inhibit FSH. And the third thing that the corpus luteum releases is high quantities of estrogen. We'll talk about how this impacts the uterus soon. in step 7 here, so the corpus luteum is degrading now. It's going to slowly release less of all of these things. So you're going to get less inhibin being released as it degrades. There's going to be less progesterone. And there's going to be less estrogen. These first two, as these decrease, then FSH is going to be able to rise again. Which we can see in this blue line in the graph that FSH is now rising in concentration as that corpus luteum has a harder time inhibiting it. And that will reset the cycle to the beginning. So, how does all of this help the ovaries? For this, we're going to look at the uterine cycle, so we can check out how the changes of hormones influence the uterus. So we're not showing LH and FSH in this graph, but we're showing the hormones of estrogen, which there's different types of estrogen. We're going to be dealing with estradiol specifically. Then we have inhibin, and we have in black progesterone. And then this graph also has a y-axis, which is the thickness of the endometrium. Let's actually write that here. Endometrium thickness. Oh, and by the way, so just so you can see generally here, there's always some uterus wall. There's always some part of the uterine wall that's there. Not all of it is going to be shedding off during the menstrual cycle. So you can see here's the uterine wall shedding off during menses, during the period, but it doesn't remove all the wall, so up until about here. So anything below this point is not going to be shed off. That's called the basal layer. So the basal layer goes all the way across. On top of that, we have the part that does shed and grow in the uterus. That part is called the functional layer. So the functional layer changes over time and gets shed off during menses. So in the phases of the uterine cycle, we have menses, we have the proliferative phase, which is the uterine wall starts to increase in thickness again, and then the secretory phase, where we're going to have some additional thickening of the uterine wall and some other things going on. So if we wanted to write what was happening more specifically, actually, let's do that in a moment. Okay, so this graph, we can see estrogen going up in concentration. So there's a little bump here in estrogen. What's going on in that little bump? You have this little bump here because of the low amount of estrogen being released from this early secondary follicle in the ovary. So we get that little bump from the early secondary follicle. And then as the secondary follicle is maturing, it's producing more and more estrogen. So here we can see the estrogen concentration is going up, peaking at a certain point right before ovulation. And then the secondary follicle is becoming the corpus luteum. So as that secondary follicle becomes the corpus luteum, the estrogen concentrations are going to go down as it's becoming it. It takes from about here to there for this structure of the follicle to become the corpus luteum. And then once it is the corpus luteum starts to secrete more estrogen. So we get an increase up until about here. And then the corpus luteum starts to degrade. And as the corpus luteum degrades, estrogen concentrations go down. Inhibin concentrations, nothing going on with inhibin initially, so it's pretty flat. It goes up a little bit here. We don't really have an explanation for that in this worksheet, and we're not going to talk about this little bump here. So don't worry about that one. But you should know why inhibin is going up in concentration here, and that's because the corpus luteum secretes inhibin. You should also be able to say, why does inhibin concentration go down at the end of the menstrual cycle? And that's because the corpus luteum is degrading. Finally, progesterone stays pretty flat in the follicular phase of the ovarian cycle. And then before ovulation, progesterone increases. We don't have an explanation for that in this worksheet either. But it continues to increase because of that corpus luteum, and then it goes down as the corpus luteum degrades. So what do these hormones do to the uterine wall? So this initial thickening of the uterine wall, initial thickening of the functional layer, is due to estrogen. So as estrogen levels go up, the wall of the uterus begins its proliferative phase. It starts to increase the thickness of the functional layer. Another thing that estrogen does is it's going to thin out the cervical mucosa. So that sperm have an easier time entering into the uterus. Normally, if the cervical mucosa is not thinned out, it's thicker, and that thicker cervical mucosa can block sperm from entering the uterus. And if it never enters the uterus, then the sperm can't get to the fallopian tube to fertilize the oocyte. So as it turns out, in a 28-day menstrual cycle, the most fertile days, the days that's easiest to get pregnant, would be days 11 to 15. Okay. Then, as this progesterone really ramps up in concentration, that's going to start helping the uterine lining finalize its thickening. So this final thickening is due to progesterone. So initially, the thickening is estrogen. In the secretory or secretory phase, it's due to progesterone. In the secretory phase or secretory phase, the progesterone does the opposite of estrogen in terms of the cervical mucosa. It's going to thicken. And this is going to inhibit sperm travel. All right, so we went up till step 7, and so just to bring it all back to this, in this luteal phase of the ovarian cycle, remember the purpose is to prepare the uterus for implantation. It does that by secreting high quantities of these hormones, progesterone, estrogen, inhibin, and in particular, the progesterone here is helping finalize the thickening of the uterus, and that's how it's preparing the uterus for implantation, by making sure it's ready, it's fine, it's thickened to its full extent that it needs to be. That brings us to step 1. So step 1 is going to be the end here where progesterone has declined in concentration enough to allow FSH to go up in concentration. And the really low amount of progesterone is what causes the period to occur on what we define as day 0. So you could also say step 1 is here, and that the low progesterone causes the period or menses on day 0. All right, so just a couple of other sort of connections to some stuff that you might be wondering. So all of this is only happening after puberty. Why is it not happening when in a female that's younger, like 8 years old? Why is this not happening? So one of the things that you need to start all this off is you need the proper quantities, and you also need the proper pulses of GnRH, gonadotropin releasing hormone, from the hypothalamus. So if the body does not produce the appropriate amount of this, then you can't have the correct amount of FSH and LH being produced to make this whole process happen. You need puberty to hit in order for the hypothalamus to release that appropriate amount. And another thing that I could mention here is stuff about egg donation. So what about people who decide to be egg donors, and what kind of needs to happen there? So generally speaking, if you're going to be donating eggs, usually in the doctor's office, they're going to want to extract multiple eggs from your ovaries. So the goal is that the doctor is going to try to get they're going to try to get several of these follicles to their mature state, and then they're going to suck them out of the ovary. In order to do that, what they could do is that they'll inhibit LH. They'll also put other chemicals in your body to inhibit FSH. And then they'll use injections to sort of control just how much FSH they want in your body and how much LH they want in your body. But let's simplify it and think of it as FSH. So the doctor blocks these hormones, so your body is not able to self-control those hormones. And then the doctor is going to artificially put some amount of FSH, probably a little bit higher than normal, to stimulate more follicles developing than already would be normal. I'm making sure that you get enough secondary follicles by the end of it. And then they'll, because remember, not all of these immature eggs have enough FSH receptors to survive. So they want to make sure to inject enough FSH to allow this to happen to a lot of them. So that's kind of the general idea. And that's about it for this one. Hope you guys enjoyed. Thanks for watching.